Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. Hope everyone is doing well in this strange times that we're living in. Sincerely hope that you and your family are safe and well. Quite a few people working offsite or from home during this time. And I just hope everybody's making the adjustment pretty smoothly. And we hope that today this will be a good presentation, some good time well spent. So we're hoping that everything here is going to go for about maybe less than 45 minutes because there's a lot within Creo 7. So we're real excited to be bringing this to you. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And joining us today, our presenter, is Paul Dye from PTC. And Paul has a presentation and a demo of different areas of Creo 7. So he's gonna do his thing. And if there's anything that you want to see in Creo a little more detail that maybe you didn't see today, if you want us to go more into sheet metal, if you want us to go more into something else, multi-body, we can always set up a custom demo for you. So with that, we also have Bill Stickney on the line, who I promote as the smartest man that I know. Bill's a pretty intelligent guy, especially when it comes to FEA and CFD, and he's been a long time user of Creo. So he is also on the line to help assist with any questions. So if you have any questions, feel free to type those into the dashboard at any time. We'll try to answer them as we go along, but we will absolutely get your question answered by the end of the webinar. So with that, I'm going to pass control over to Mr. Paul Dye. Paul, you have the baton.
Sounds good. Can you see my screen?
Yes, I can.
Awesome. Okay. Well, thank you everybody for joining. And again, like Rob mentioned, my name is Paul Dye, and I am an application engineer here with PTC. And in general, what we're going to go over is some of the new stuff with Creo 7.0. And with this, obviously a lot has changed and been improved with the release of Creo 7.0. So more than we could cover in just, even 45 minutes. So what I'm going to do is focus on some of the main ones here. And as we go through, feel free to type in questions, anything that we might need to elaborate more on for you can definitely do that. And then throughout this, I'm going to show a couple of different demonstrations of some of our different capabilities, mainly into some of our capabilities around Creo Simulation Live and also with generative design. So without further ado, we can jump ahead right into it. So first thing that I want to talk to is around just some of the new core modeling features that we've introduced with Creo 7.0. First thing that we have here is improvements to the import data doctor. And this is important if you're going to be bringing in non-native geometry. We now have support for things like multi-body, which is something that I'm going to go through and talk to a little bit here in Creo as well. And on top of this, we also have a troubleshooter looking for things like open quilts and how we go about finding and fixing those. Something that's important whenever we're bringing in non-native CAD data. On top of this, we also have new display filters for geometry representations. When you're showing off different representations, we've kind of improved your ability to show off those different features. So for example, here, if you wanted to highlight on these lattices while having the rest of the part be more of a translucent, transparent display, you can go ahead and do that. We have a lot of different ways to build those out. So that works in very well with things like combination states and really just a lot of different ways to play around with that. On top of that, we have improvements and enhancements around the draft feature. So this is something that we've been working on with the past couple of releases of Creo. And what we've included here is things like drafting already drafted features. We also have the ability to detect existing draft angles right in the model. So it makes it very easy to work with and modify later on. So definitely an important feature if that's something that you work with pretty often. Here we also have improvements to the performance of snapping to the model geometry or maybe to a grid, and we have now more control over that. So now we can quick menu over certain areas, switch that on or off, depending on what you're working on. So that's a really quick way to work, especially if you want to snap to edges, snap to surfaces, and you can change that as you're working. If one point you want to, one point you don't, very quickly change around between those. And we also made enhancements to the mirror tool in the sketcher. So So this is something that we made it very easy to grab things and mirror across. Now we can essentially grab any straight sketch and use that to mirror about. And you can move that around, you can change it up, and then the mirror feature is going to update whenever you go through and make those changes. It's going to be much more reactive as you're working with it. And it also made improvements to the visualization of your design intent in the sketcher. In general, we've improved the look of the relation icons, able to highlight references, change colors, really just modernizing the look and the feel for working in that sketcher, making it very easy to display some of that intent as you're going through and building out these sketches. And in the edit dimension section, you're able to set the appearance of your sketcher constraints. So when you click to edit any of those dimensions, also show the constraints. That's a config options that you have there to activate and work with now. Those are just a couple of the main different core modeling things I wanted to go over, but now I want to look into more of the applications. So starting here first with Creo Simulation Live, aka CSL. And if you haven't seen this before or worked with this in the past, this is a tool that we've developed as part of our partnership with ANSYS to put real-time simulation right into the modeling environment. So if you've worked with FEA in general in the past, this is a lot different. This is something that's taking it and really expediting the process, making it something that's really valuable and really useful for our designers. So instead of our designers simply just working with the model and kind of basing their intuition, saying, I hope it's right by the time I send it off to the FEA analyst guy, none of that. We're able to work with it right in the design environment and get those type of results back right as we're designing. And there's a lot that we've worked on and really built out with this tool. And so specifically here, whenever we're working on defining loads here, we're now able to set the direction vector defined by a selection. So essentially, you don't have to work with the default or even type in any of those values. You can essentially just click a surface that's right in the model, and it builds out the X, Y, Z direction for you. And building off of that, we're now not locked to working with just the global coordinate system. You can select any coordinate system to define those load cases from. So it's just improving the general ability to define those loads at the start of the study. We've also made enhancements to the legend, specifying what you want to look at, how those values are displayed, and especially setting the upper and lower bounds for the values that you're displaying. This works very well with things like a composite view, and that's where you're only showing values within a particular region. So say we were looking at our von Mises stress, you could say, I only want to see values between 6.2 megapascals to 14.7. And so it's going to essentially gray out any of the areas that aren't seeing that. You're only viewing that. So it's really easy to visualize right in the modeling environment. And we can also get values that we get from our simulation probes here in CSL, and we can move those probes over and use them in our behavior modeling studies. What behavior modeling does is something that works as a base in Creo and allows us to take values like your maximum von Mises stresses or your displacement or heat flows, that sort of thing, and actually optimize around it, where we tell the system certain dimensions that it's able to change, and the system automatically goes through and optimizes the model for us based on the variables we allowed it to change. So that's a very useful way of using some of those analysis results we're getting from CSL. Looking at a couple of our real-world simulation constraint types, we now have things like ball, pin, planar constraints, just more helping us to make each of those cases more realistic to the problem or the situation you're trying to design around. One thing I'll go through and talk to in a little bit is just around now that the fact that we have, with a lot of our different applications, support for multi-body design. There's a ton of different applications of that, things like creating cavities, internal, external volumes, different flow domains, and much more around those. And specific to thermal studies in CSL, you can now do transient studies, aka time-dependent analysis. So it allows you to see how your results are changing over the course of time. So now either do the steady state or the time-dependent with that transient study. And then moving on here, probably the biggest change to CSL with the release of Creo 7 is now the option to do flow analysis in the same way that we would normally do for things like structural, thermal, or modal, or essentially starting by creating the fluid domain, saying which areas to include or exclude, define the inlets and the outlets, also specifying the materials for those fluid domains, and from there, visualize it right on top of the model that you're working with. And that's the idea here, is regardless of whether it's an internal or an external case, be able to visualize it right in the model environment. It's not some other software, another window, or anything like that. You have to switch over and work with it. You just do it right in the same user interface that you're kind of used to working with in Creo. Along with that, there's a lot of different options for the results that you're getting. You can visualize streamlines, particles, take section views, direction fields, set probes. It's a really powerful and at the same time easy to use tool for doing that type of flow analysis. Normally, this wasn't even something that's standard available for your designers. It's just something that tends to cost a lot of money or takes a lot of time and experience to work with. It's not something that, now working with CSL and doing this type of flow analysis, we don't have to send it off to that expert analyst to get some of these results back. Something that we can do right in the design environment. And that's something that I can take us through now and take a little bit of a look at how we actually do that here. Allow me to bring that model up that we're going to work with. And so for our demonstration,
I like that you're doing the demo after doing the presentation on the whatchamacallit, on the solution. It's
definitely good to.
It flows a lot better than going through everything and then going back. I like it.
Yeah, I think so too. It gives a little bit of context into what you're talking about. And so rather than just reading it off of a slide or hear me talk about it, it's better to hear it and then allow you to visually see it right in the context of Creo where you're actually going to be using it. And so this is the model that we're going to work with. So this is actually a muffler design off of one of our customers' data sets from Royal Enfield. So this is the muffler off of one of their motorcycle designs. And to start to take a look into this, what we want to do is simulate some of the flow that's happening within this system. So let's start by taking a section view to kind of see what we're starting here. So there's definitely a lot of great geometry in there that we're going to be able to utilize and begin to kind of change around and work with as we move forward. And to start into that, we'll simply just go right up into the top, into our live simulation tab, and click to start into a fluid simulation study. So we can see here we have a few different options that we can go into in CSL, where we can do something like a structural simulation, thermal, modal. In this case, we want to do that fluid simulation. And the first step that we'll take whenever we go into this is to lay out the fluid domain. What the fluid domain is the volume of space that our fluid flow is going to be contained within. So here, to do that, we're going to first start by defining what our inlet is going to be here. And again, this is an internal volume that we're going to define here, but you could also use Boolean operations using multi-body, or you could define more of an external flow that would be flowing around this, if that's something you want to look at. In this case here, we want to define what our inlet's going to be, where that fluid is coming in, maybe from our exhaust. We define the outlet. And once we do that, we can see that the system automatically builds out the internal volume for that model. And once we accept it, that now appears down in the model tree, and it's something that I can go back to and make any type of changes later on if I'd like to. Once we have that laid out, we can then define the fluid material that I like to analyze. So we have a few different options already built out here. In my case, carbon dioxide is going to be a very close approximation for what's going to be coming out of my motorcycle. So I'll go ahead and select that, and we can see that laid out over here in our simulation tree. Next, I can set up our fluid flow velocity for my muffler. Essentially, how fast is this going to be coming in from my motor? Specify the surface that I want to work with, set the direction, set the magnitude for any of those. Like I mentioned, now we can simply just select that direction right from the modeling environment. We don't even have to type in any of those values. So it really helps if our models are laid out in different orientations or just not kind of standard like it is right here, which is pretty easy. It's just right in the negative X direction, but just another way that we can go through and lay that out. So we can lay out the magnitude, change around the units, and we're good to go. And so now that I have that flow velocity set up, we can then set some thermal conditions. Maybe we have a prescribed temperature at that inlet. We can set that value, set the unit to whatever really regular operating temperature might be around that motorcycle exhaust. So that looks pretty good there. Lay it all out, and we can go back and reference that. And I'm pretty happy with some of those initial conditions I have around that inlet now. Next, I want to move back to the outlet and define maybe an outlet pressure for my muffler. And looking back here, in my case, I'll simply just set it to 0, essentially just going to be mimicking outside air. And with that, I'm pretty much ready to jump into the study. There's a couple options we could change here for our simulation quality, where we can move it all the way over to the left for the highest speed. We could either keep it all the way to the right for the highest accuracy, or maybe somewhere in between if we'd like to. In this case, I'm going to keep it all the way to the right for the highest accuracy. With that, we can simply go ahead and click to simulate. We can see essentially as soon as I click to run the simulation, we're getting results back. It's really that fast. I have the ability to change things over in my legend if I only want to see the velocity within a particular range. I also have different display options that I can choose from to visualize the flow of these individual particles moving throughout. And with that, even more options for those particles to change the size, change the transparency, really getting this looking the way that I want. Helps me to understand exactly how that flow is working, depending on how I set my model up. So those particles are really one really good way of analyzing that flow, but we can also look at other things. Like here we have our direction field, which essentially acts as a cut plane that I can use to see the direction that everything's going. I can move that cut plane around to different parts of the model. Here I can pull up my dragger tool and change that around. I can check out the direction that my fluid is moving based on how I went through and defined it. Really helps me to interrogate certain areas, even type in specific values for that section view to kind of move it around. As we can see, there's a lot of ways to visualize those results, but on top of that, also analyze and begin to build off of that. So starting first here with our live simulation probe. What that does is allow me to see different values of my model, such as the max velocity that we're getting down at our outlet. Now we can see how that changes over the course of the flow. Once we have that, we can see the graph for those values and see how they're changing. It really helps us to see what's happening down at that outlet. We have other options we can change through to see the pressure, temperature, vortices. So now these are all things that we can actually begin to design around. And one of the best ways in Creo that we have to do that is by working in the design exploration. So this is something that is just a tool in Creo that we have for trying out new design ideas, iterations, branching off of existing designs. And instead of how we would normally do it by making lots of copies and doing save as all the time, we work right in this one exploration session where we start into the session with a pre-modified version of the model. And as we go through and make changes, instead of saving off a bunch of different copies, we simply just make checkpoints at any place that we might want to check back on or branch off of. In this case here, we can go through and change some of these internal baffles. What's going to happen if we want to make them a couple inches longer? So we can see, even though we're in this design exploration session, we have the flow analysis running, we're still able to do this standard sort of CAD Creo work that we're used to. But the difference is now, as soon as I make that change, we're getting instant insight into what that does to our analysis. I can go back and check out different things. I can check out what that does to our particle flow. We can check out, where we're seeing jumps in values for those surface flows, see what the velocity is doing there. Check out the pressure here, see how that's changing over the course of the flow. So this isn't something that, again, I save on or send off to the analyst to hope to get results back by the end of the week. Something I make the change and I see the result. So we can see that DEX, or the design exploration extension, is keeping track of all those changes I'm making. What that allows me to do is keep making more changes to the design. So maybe in a past design, I built out these pipes or these baffles with holes in them. Well, I want to see how that design would work if I activated those holes. So do that right down in my model tree. And as we go through and make that change, we can immediately see, that's a very different type of flow down by our outlet. And we can check out the probe. We can check out the graph of those values, kind of clearly see that we've started to increase that outlet velocity, but we're also able to check out other values as well. Maybe switch to that composite view, see how the velocity is moving throughout those pipes, check the pressure. Seems like we really smoothed out the pressure flows throughout that model. It might be useful in order to see maybe where our max values are occurring to the model. And similar to how we did with the direction field, we also have the ability to take kind of true section views and see what's happening at those different parts of the model. So let's move around to the back end here and take a closer look into that flow that's going through these holes that we added into the pipe. So we can see the difference with, and also with that direction field here. We can actually see we almost reverse the flow through those holes in the baffles and those longer tubes. So I'm definitely happy with the changes I made so far. And if I want to capture that design intent, I can make a checkpoint here again to show right where I was whenever I went through and made those changes for the holes. Something that I can check back on, switch between different checkpoints, to really start to capture the work that I've done throughout this design. I'm pretty much happy with where I'm at towards the outlets. Now I want to direct my attention more towards the front end of that flow. So right now we pretty much just have some solid cylinders with a bunch of pipes going through them, right? But I want to change up that design. And if I want to change that up, first thing I'll do is clear out the feature that I have right now. Instead, start with more of a clean slate that I can begin to add to. I'm also going to use one of our multi-body commands here to very quickly remove that body from the model. So with that area now cleared out, we can begin to build out some new geometry there. what I actually want to do is add in a lattice feature that's going to regulate the flow through our channel. This could be something that we might be creating using additive manufacturing. And to start with that, there's really a lot of options. We'll first begin by specifying the surfaces or the area that we're going to use to define where that lattice should be placed within. This is what we call a lattice region. We'll simply go through and select any of the edges that we want to define that region. And latticing is a feature that is something that we've had a lot of focus on in Creo over the past couple of releases. It really gives us the ability to create some very robust, complex structures that have a lot of different uses, especially if you're working in the world of 3D printing. It's very quick to go through here, define our coordinate system, where that first cell should be located, and then we can define a little bit about what that cell shape should look like. And we can do lots of 3D shapes, or kind of like what we're doing here with more of a 2.5 shape in the shape of a hexagon. And we can size that down, scale it, change out some of the parameters. Maybe if we see this, we see those wall thicknesses are a little bit thin, so we can scale them up more. We can visualize what that would look like. And if we're happy with that change, go ahead and accept it. Again, even though I made a fairly significant change there, see the analysis, it's already been updated. And then we can go through and analyze the effects. Change the display types, change the result types, even go through and see how some of my different values are affected. We want to see how our pressure flows have changed throughout that. And see maybe there's a pressure drop in the middle there now. We can check back around at the velocity of the outlet of my muffler and kind of see where we're getting those spikes in those values. So it's very clear to understand and very quick to go in and see all of these different values. So once we had a chance to look over those results, and because I'm in Dex, we can build out a checkpoint. It allows me to see exactly the changes I made in order to get there. If I'm happy with where the design's at, I can choose to accept those changes, and then those changes are now applied to the parametric model that I started into the session with. And even though design exploration is a great tool, I don't even have to be in Dex to make the changes to the model. This could be a day or two later where someone on my team is saying, hey, Paul, we need to decrease the outlet velocity. Well, I know to decrease that outlet velocity, a good place to start might be around that diameter. Probably going to want to increase that a little bit. Once I make that change, we can simply just regenerate the model. And then my analysis updates right along with it. And I can go back now, check out the probe, see the values that we're getting for that velocity. They definitely dropped down a bit. And now we're seeing right around 250, 240 meters per second. And that's really the idea with flow analysis in CSL. It's making any of the changes we want. Try this, try that, try anything. We don't want to limit all the amount of creativity that you can have in your design by having to wait around for results to come back from the analyst. We simply just build out the model, us as the designer, and immediately get that type of insight back. Right? So that's a quick look through that. And if that's something that you'd be interested in getting more information around, that's definitely something that we can go ahead and give for you. But that is a quick look into how we do that type of flow analysis in the context of CSL. And if you don't work with CSL at all right now, we do that for multiple other ways as well. We have structural examples, thermal, vibrations, really a lot of different use cases you can get into there. But moving forward, we're going to take a look at some of the other sections that we really want to highlight here in the release of Creo 7. So the next step that I want to look into, one of the big enhancements that we're going to cover is around multi-body design. So this is offering a new way to design in the context of Creo. This type of multi-body design methodology allows you to be flexible in the way you design your parts in the model. So with these, each of these bodies can be handled differently. Different materials included or excluded from your mass calculations, how you define your global interferences or clearances. So there's many options around that going forward. And these bodies are a new type of object in the context of Creo. They appear right in the model tree under the bodies tab. Each of those bodies can have all of their own individual appearances, parameters, attributes. And with each of those, we have the different operators for working with that geometry. So merging, subtracting, intersecting. And once you've done what you need to do, you can go ahead and make part files out of any of those bodies. It's a really powerful way to work in a lot of different contexts. If you've never worked with multi-body, it's definitely something that you'll probably want to try out. For some people, the standard way that we're used to working in Creo is going to work just fine. Still an awesome way to work. But for a lot of people, this type of Boolean work where you're merging, subtracting bodies, it's going to open up a new world of possibilities. So doing this type of multi-body design could get you there a lot faster and easier for some geometry, as opposed to maybe your typical surfacing and quote-based workflows, where maybe for something like we just saw with the CSL flow analysis, that could be a good use case for multi-body, where you want to have some of these different bodies built out for the internal flows or some of those flow domains. So a quick look into that. And we also had improvements over in the world of additive manufacturing and 3D printing. So first here, we've made improvements to the creation of stochastic lattices. We've enhanced the way that these type of lattices kind of follow along some of those hard edges that we have in some of our parts. So it's making those structures even more structurally sound. This is really useful for a lot of medical purposes I've seen. This is something where if you're creating things like bone grafts or things of that nature, really cool way to build those out and something that's really useful. We also have improvements to custom lattice cells. Custom lattice cells are where you're taking a part file and you're using that as the cell for the lattice. So where in the past we've had the option for full geometry, we've now included an option for a more simplified B-rep geometry as well. That's helping if we're going to have, 100,000 of these different cells. It's really helping for that cell propagation. And then specific to the additive manufacturing plus extension, where you're doing more metal 3D printing, we've made improvements to the tray assembly definition using that multi-body design methodology. So even within the same part file, you're going to have different bodies with different parameters, wall thickness, colors. So a lot of different uses there. Right, and looking at almost the opposite side of things, we've also made improvements over in the world of subtractive manufacturing, so more in the world of machining. The first ability here is we're now able to view synchronized tool paths right in the graphics area, where we've always been able to synchronize those tool paths, but now we're also able to use a synchronization menu where you can highlight the ones you want to see, view them, and keep track of all of that. And here again, we've also had the ability to use the go home command always, but now some machines that we work with need multiple different go home positions. So especially if you have mill turn operations, you can have home 1, home 2, home 3, whatever you need with those. And then finally, the ability to explicitly call out Swiss turning operations. It means if you have a mill turn machine, you can fix the Z-axis and put all in the appropriate CL commands to that output file. So if that's something you work with, that's definitely something that you're going to get great use out of there. Okay, moving on, we're going to go through and take a look at some of the changes we've made to support the work we do in detailing and model-based definition. So this is something that has been built out over the course of the last couple of releases of Creo. Something that we really have a big interest in is building out your ability to work with detailing and especially how that relates into model-based definition. And first, of course, we've included multi-body support for our drawings. If you have different bodies with different materials, even if they're in the same part, you can go ahead and make different cross hatchings to differentiate them. You can have different repeat regions in the drawing for multi-body parts, exclude certain bodies, include all of that in your tables. And then over in the drawing model tree, you could have control of those different bodies. So you can identify them, hide them, so your ability to keep it all straight. We can configure drawing view tooltips. So if you click on that view, you can see what the part is, the model, combination of the explode state. On top of that, we have a new summary view command where we can click on an element and have the system tell me about it. So it's a good way to understand the design intent, especially if you weren't the one who created the model itself. Improvements around the addition of drawing tree columns, so adding those in now is an option. And around that, being able to sort the drawing tree by view models and parent views. So building out that drawing tree the way that you like. Okay, next, improvements to removing hidden lines. If you have a view that you want to remove some of those hidden lines, that's something that's very easy to do now. We made improvements in that certain area. And here we can also move the arrow that we have associated with our annotations right with the name. So you can actually link the two, where whenever you move the name around, the arrow is going to follow. You can also delink those as well. So it's not going to be linked. You have options around that. And also the ability to add multiple different leads. This is an option where you can have multiple normal tangent leaders all coming off of that one common annotation. It's a really helpful way for building out those GTALs, notes, symbols, anything around that. And looking into a little bit around our model-based definition, we can now align ordinate dimensions with the baseline. This is something that if you're going to work with the ANSI standard, it's how they like to do it. So we've built out those ordinate dimensions to work well with that baseline. Around that, we can control the length of intersected contours. So beyond just that intersection point, you can enable certain intersection witness lines to control how those are working. And then we have a child view identification. So it's very easy to see where your drawings go to, where they're coming from. It's especially useful if you're going to be working with a multi-page drawing, or again, even if you were the one that maybe didn't create the drawing, you're just looking at it, it's helpful to keep all of that straight. And continue to make improvements around GTOLs. So now we have additional indicator values, things like intersection or collection plane for angularity. In that case, it's going to be for the ISO standard. We also have options for controlling the gap between the GTOL and the indicator frames. So depending on the standard that you're working with, depending if you're using ISO 1101, 2012, or 2017, you're going to have different options for that potential gap size. And around those just standards in general, as they keep getting released, Creo is going to keep evolving right alongside them. So now I've included the support for that ISO 1101 2017 and also the ASME Y 14.5 2018. Right, wrapping up here with some of the options for the alignment of spacing when it comes to composite GTOLs. So depending on how you want those GTOLs to align, on the left, on the right, that's all done keeping up with those standards. We've also added some new symbols to the symbol palette, so particularly the angularity symbol for an intersection plane, the runout symbol for a direction feature, and the symmetry symbol for a collection plane. So if you work with any of those, that's a nice added feature around that. And finally, we've updated the parser for the syntax checker. So it's again taking those new standards into account. So definitely a lot of work being done in the area of detailing MBD, something that you are really going to want to work with if that's something that is important to you. And one of the biggest developments that we've had with the release of Creo 7 is the introduction of Next with generative topology optimization. So with that, generative is, I guess, at a very high level, autonomously creating optimal designs from whatever set of design requirements you have. And so with Creo, you're able to specify requirements and goals, and then the generative engine is going to automatically produce a manufacturable design, either as a starting point or as a final solution. Allows you to try out different materials, physics, manufacturing constraints, and automatically generate that geometry. It really allows you to try out a lot of different generative design studies to explore all the different kinds of design alternatives. And you're able to visualize all that real time, all that generation, even if you're modifying the input geometry or any of the design criteria with that. So it helps us to go through and really see exactly what type of geometry we can build out without knowing exactly where we're going from the start. We can interrogate it, we can review analysis results, see where we're getting stress values, what the deformation is. As you start to get those results, go back and change things, change design constraints, any of the geometry, try different materials, and see what that does to the geometry that you're getting. And we're able to do all that because it's integrated right in Creo. So we've integrated this Frustum technology right into the modeling environment. So it's not some separate window or software we have to switch over to. All we do is define the geometry, say what we can change, say what areas we can't change, and just let the system go. And once the system generates the design, we're able to review it. And then once we do that, we're able to take that design and actually convert it to solid BREF geometry. So in that process, you have different options for how that model is reconstructed. You can go back and forth between the two, kind of see what's changed, and do that to get the best model possible with actual manufacturable geometry. And this is something that is great to talk about, but again, is going to make a lot more sense once I actually go through and show it here. So we can go ahead and pull up that model that we want to work with. All right, and so this is going to be working off that same motorcycle design that we pulled the muffler from. In this case, we actually want to take a bit of a closer look up at our steering wheel assembly. All right, and so particularly, I actually want to look down at this lower yoke. And right now, it works perfectly well. But this is something that I want to see if I can cut down on some of the material around it. Now, I might know some of the design goals that I'm after, but I'm not exactly sure how I'm going to get there. Well, that's something that is a perfect candidate for generative topology optimization. Let's go in here and go ahead and find that part that we want to work with to go ahead and build out one of our generative design studies. All right, so here we can see we have that same yoke part, but a little bit more of a simplified version of it. But this is going to be the base for what I'm going to begin to work off of. You see that we have sort of an overall envelope of where that part's going to be contained within. And then I have my preserved geometry. So that's the area that I want to keep. And I can begin to build out in the middle of that. And to begin, I'll simply go up into my Applications tab and select our generative design. And so the first thing we'll do is select our starting geometry, which is going to be that overall envelope we saw. And next we can select our preserved geometry. So that's again, the area that we want to make sure is going to be included in our final design. And from there, we can lay out whatever physics we want to study. In this case, we can lay out our constraints for the study, say where that part might be held down or simply welded, and then go through and apply some of the physics like the loads that we want to look at. So this could be forces, moments, pressure, centrifugal forces. In this case here, it's going to be along these outer parts of the yoke. And once we have those different loads laid out, any of the magnitudes, the units that we want to study, we're good to keep moving on. In this case here, I want to actually lay out some of the design criteria that we want to build out with this, what our goal is going to be. In this case, I'm trying to take out some weight, so maybe just fill about 2/3 of that volume. And then from there, we can look at some of our design constraints. So we have a lot of options around this, so we can lay out, if we're going to be building out for additive manufacturing, we're going to have to take into account the build direction. If we're going to be doing it for a cast, we might want to do a parting line, or it could be something like a geometric constraint here. So in this case, I want it to be symmetric across a certain plane. Maybe that's going to be right in the middle of my model. So we'll lay that out. And then lastly, I'll say what type of material I want to use. So we're probably going to get different results depending on what we choose there. In this case, I might be working with an aluminum alloy, and that should essentially cover everything that we need in the design criteria. And before we go ahead and run this study, there's a couple options I can change for the fidelity of the study, how many iterations we want to run through, the minimum element size for whenever it builds that out. And once we select all that and we're happy with what we've laid out, we can go ahead and click to optimize. And so now the system's taking those physics and the design criteria and it's automatically building out our design. We can visualize all those steps that it's taking, and from there, analyze the results right from our study. So right on the model, we can take a look at our von Mises stress, see where we're getting minimums, see where we're getting maximums, and then go ahead and really start to interrogate this, move up to the top of the model, check out where our hotspots are going to be. Also check out the displacement, maybe see if this part's deforming in the way that it should be based on those loads and the constraints we set up, and even take it one step further with that and animate on the deformation. We have options to change the speed of that animation, change the scale, so that it's a very visual way of doing it. And if we're not happy with the results that we got, we can easily go back and make any changes to the definition of the study. But if I am happy with what I got, I can actually choose then now to generate the design. I'm going to take that tessellated geometry that I have now and reconstruct it to a boundary representation, aka BREP, that I can take over into Creo parametric. So rather than being stuck with just that tessellated file, we can get real manufacturable surfaces that we can now start to work off of. And so now Creo is going to go ahead and reconstruct all that geometry that we just went through and built out in our study. And now it's all part of that Creo model, something I can add right back into my part. So simply just using some Boolean operations to merge our new geometry and add that back into that preserved geometry that we started with. And just like that, we now have a solid Creo model that's ready to go. But what happens now if we need to make changes? Maybe at this point the model has to change. Maybe the outer diameter moves. Does that now mean that I have to go through and start my study over from scratch? Well, no. All we do is simply go back in and change whatever we want to look at. Put in our design control, or our design goals, our constraints, kind of like we did earlier when we were looking at our part limit volume, changing around the constraints where we want it to be symmetric about that middle plane. But in this case also, I want to change in another constraint. So this might be now building out for a different manufacturing style. Maybe we don't have a 3D printer to go ahead and create these. Well, I can add in that linear extrude constraint. So now it's going to be possible to create using that manufacturing technique. So it's really whatever your specific scenario calls for. So even if you have changes, you can see it's really easy to go back and redefine. You can change the fidelity, increase the number of iterations, and we just simply let the system do its thing. In this case, I've already gone through and run this study before. So instead of going through and running that again, we can go ahead right back into our file explorer and open up the result that we got after converting to the BREP geometry. And so whereas before, our design was really only possible creating it using it as a manufacturing, this is something that could be manufactured other ways like milling or casting. we can add that geometry out back into the rest of the model, and we're good to go. And that's something that we could take over into our simulation tools, like we saw with Creo Simulation Live. So instead of maybe something like a flow analysis, we could do even a structural study. So work with the constraints and loads we have set up and click the simulate. And just like we saw earlier, it's pretty much as soon as I click to run that simulation, we're getting results. And now I could go back and try out all kinds of different designs through generative and then reconstruct the geometry, take those constraints and loads over into my simulation and see what kind of results that we're getting. So looking at the results that we're getting here, it's definitely different than what I would be getting working with that additive model. So deformation has definitely changed around those outer holes. You can again animate on that to really see how that's working in the context of our design. And so from there, we could take that info, run more analysis if we'd like to, go back in to build out more designs, or really wherever you want to do there. At the end of the day, you're able to go through and really innovate and at the same time create structurally sound models that you're going to be able to use going forward. So something that's really an awesome enhancement in the world of Creo, specifically with 7.0, something that you're definitely going to want to check out if you're really building out these type of designs and doing that type of work. Or even if you don't think right now that that might work in with your processes, there's a lot of different use cases where that works, where we've seen people be able to take this, and if you have an assembly that normally takes 10 different parts with 10 different manufacturing techniques, you can take that down to 3 parts with 2 different manufacturing techniques. So a lot of different ways to really build that out, but it's something that's now available through the use of Creo 7. So a couple of other applications I want to touch on before we begin to wrap up for the day. So the first thing is around our render studio. So there's a few new options in here as well. The first thing is the ability to pause and resume during the rendering. So normally when you're in this mode, it's kind of constantly running by default. But now if you know that you're going to go through and make a couple of changes, you can simply just pause that render and give your computer a break while you're going through and making changes. You can also now render the mannequin vision window. So what that is we have these mannequins that we can use in Creo, and we're essentially taking the view that that mannequin can see. We're able to render that view to get some really nice shots of our different models. We also now have the option to define a custom floor plane for that render. So it allows you to flip the model, change where the shadows and the reflections are going to appear. Now you have that level of added customization. Had improvements over in the world of augmented reality in Creo as well. So this is where we're able to view these models as augmented reality experiences. If this isn't something that you've worked around, this is again something that's part of base Creo, that you can take these, and instead of just sharing off pictures of a design, you can actually share out these augmented reality experiences of your designs that your customers or other people internal or whoever it is can pull it up and actually see it right on their desk. So there's a lot of things that we've built out around this. Now specifically, we've included the ability to publish out different combination states as part of that experience. So those combination states can include different exploded views, sections, different appearances. So that can all be included with the models. And with those different states, the user can switch between each of those. So very quickly and easily switch from one view to the next. And you have these different view options when you're publishing out over to Vuforia View. And Vuforia View is our free to download, free to use application that people will use to actually pull up and view those augmented reality experiences. So definitely something that's really awesome and is a really great way to share that type of design intent and the work that you're doing around the designs. And then finally here, I'd like to just briefly go over a little bit of the improvements we have to the easy tolerance analysis tool in Creo. This is formerly known as the tolerance analysis extension. So if you haven't worked with this tool before, this is a one-dimensional tolerance stack-up analysis tool powered by one of our partners, Sigmetrics. And this is used to perform these tolerance analysis right in our Creo assemblies. And this is something that you can do right from the Creo design. It works right from the annotations for dimensions, tolerances, GD&T information, where as we make changes, we can have all those different changes propagated to update the analysis. And with this change into the easy tolerance analysis, we've done a lot to update the look and the feel of the tool, made it even easier and faster to do these type of dimensional stack-ups. And we can define multiple different stack-ups per model. We can evaluate the impact of a lot of those studies to look at many different things. We can look at statistical results, defects, worst case scenario, RSS, all these things that you can look to see exactly whenever it's time to go manufacture these parts, how robust is it going to be? How many parts per million are you going to have failures. So you can even see which annotations have the highest contribution to those. So if you have one area that's causing a lot of failures or really contributing to the results you're getting, you can maybe go in and tighten up some of those tolerances and get better results through that. All right, and with that, that's really all I wanted to go over today. So that's, again, a lot of different information there, a lot of things that maybe relates to your process, maybe it doesn't, but now you know kind of a lot more into what you have available, especially going forward with Creo 7. With that, I can pass it back over to Rob, and me and Bill could take any questions that you might have, or maybe anything that you need us to elaborate more on.
Excellent. Thanks, Paul. Nicely done. So as you can see, there is a lot to Creo 7, and we're just kind of scratching the surface here and giving a generic overview to everyone. We have some questions coming in. So one of the things I want to do is just a quick survey on Creo 7. If you want to see any further information, can you see that poll there, Paul?
Let me see. It says organizer must close poll to enable screen share. So I think so.
Poll must be
not
closed.
Very well.
Oh, okay. So it's people can see it, so that's good.
Okay.
So, all right, because they're checking off box. So if there's more information that you want, whether it's sending you some info or we're doing a custom demo, we can do that on whatever makes more sense for you. So I'm gonna leave this open for a little bit. One of the questions that came in was, can you base the optimization based on multiple loading conditions or criteria? For example, a vertical load separately from a side load, or a stress limit and a displacement limit at the same time.
Yeah, so you can lay out, and I'm assuming this is in the context of Creo Simulation Live, but that is something you can do. You can lay out different load sets. So depending on if you have different load amounts or different just load types, you could lay out different types of loads. So you could have a pressure force, you could have a moment, you could have a linear acceleration, and you could do the same thing over with the constraints. You could define kind of predetermined displacements on the model, and that could be separate from the fixtures that you set in your constraints. And I guess the short answer is yes.
Okay. Next question. Can you do generative design locally? That's there's a series of questions. Can you do generative design locally? Does the software consider all directions, magnitudes, forces, torques all at once? For med devices, has any software validation been conducted? And price of the software, we're going to discuss that in a little bit.
Yeah, so I think in the context of generative, you can lay out multiple different load cases to analyze there, kind of similar to what you're doing with CSL. Could you repeat over that generative part again? I just want to make sure I'm hitting on all the parts of it.
Yeah, it says, can you do generative design locally? And the second part of the question is, does this software consider all directions, magnitudes, forces, torques all at once?
Yeah, so it will take those into account all at once. And in the context of the question, if it can be done locally, I believe just run on the machine that you're using. And so yes, it's just another application that you're doing. It's just in the same way that you would go into something like Creo Simulate or CSL or the piping and cabling. It's just another extension right in there. But one thing to mention there too is one of the things that's being built out going forward into the future of Creo is actually the ability to do more cloud computing, actually. So that would be one of the goals going forward. Again, this is a very new technology to Creo, something that was just released, I think, 3 weeks ago now. So going forward, there's going to be an active work towards being able to do more cloud computing around that. So you could actually just set up the designs however you want to do it, and then share it off to the cloud, and it's going to go through and do all those computations for you, and it's not going to inhibit anything you're doing over on your side locally. And once it's done, it could feed out maybe some different studies for you, see the results from that, and so it's not going to bog up what you're doing parametrically. You can go ahead and kind of keep doing everything that you'd be used to doing parametrically, and then have those all be running separately from what you're doing here locally. So just something to mention there around that. In terms of
Rob,
the yeah, go on.
Rob, this is Bill. I wanted to comment on one of the questions here. First off, with respect to generative design, you get to define the volume that is being optimized. You would create it as a body, which you can do in 7 now. So you can optimize a small piece of your design if you wish, if that was the question. The other question is with respect to the boundary conditions and loads. It is common in optimization to have to design for more than one load case, and it does all of them at once. However, you do have the option of going back to the model tree and simply suppressing the ones you're not interested in. So indeed, you can use multiple load cases. It just does whatever is active, it does it at once. And if you want to do a different case with different loads, no biggie to do that. I would point out also that this is extremely fast. Compared to other optimizations that I've done, it runs in a fraction of the time. One of the reasons it does that is it's capable of using GPU acceleration, although I don't think it's required for the generative design tool. That's all.
Cool. Thanks, Bill. Next question about topology. Can you better, this might be for you, Bill, can you better visualize the design comparisons? For example, see the FEA result differences between the AM and the traditional part.
You'd probably want to use the design exploration tool for that. So I can keep multiple versions available, and that way I can visualize them. I'm not sure if you can put them on the screen at the same time, but you can certainly have them both in the same session.
Yeah, and that is a good point. You could simply have that design exploration up where you have the different checkpoints built out, and essentially just click between them, and it will update the results that you're getting from the analysis for those new updated designs.
Cool. Next question was, what level of computing power was used for the live analysis?
Yeah, so for the CSL, I guess the thing to touch on there is that with CSL, there's no CPU requirement. You know, it just runs whatever your normal recommended CPU requirements for Creo. It's the same thing, but it does require the use of a NVIDIA CUDA enabled graphics card. That's something that ANSYS actually partnered with NVIDIA to create the Discovery Live engine that was used to run CSL. And so that's something that is essentially one of the only requirements for running and working with CSL, and that it has, the other side of it is that it has to have 4 gigabytes of video RAM to run off of. And I think the one that I'm running right now is a Quadro P4000.
Mm-hmm. Next question, does running, I sent this to you, Bill, so I hope you can see it. Does running multiple load cases get you a different geometry for each case, or one geometry that works for all of them?
If you're running them separately, you'll get different geometry. If you combine all the loads together, you'll get a single geometry. The trick there is how to do the weighting, because one load case could be more important than another. And there's no special tool for that. You just go in and adjust the loads. And if you have a load that's less important, you just give it a lower value. It's extremely simple. So balancing optimization load cases is well known in the industry as being a bit of an art form, but you can certainly do it here. It's not difficult.
Cool. I'm going to take back control for a second. Right now we have all the questions answered, but if somebody else has a question, feel free to plug it in.
Yeah.
I gotta figure out how to take back control. Isn't that crazy? I've done this 1.5 million times.
Yeah, I'm gonna try to give it to you.
There we go. Thanks, Paul. So hang on, before I show it, I need to do this. There we go. Yeah, I've only done this 1.5 million times, so it shouldn't should be a little smoother with it. So there's a handful of offers for Creo, and we want to get everybody out of here quickly. So when you one of the offers is when you purchase a new license of Creo, whether it's Creo 7 or if you want to use an earlier version like Creo 5, and that's the thing is that you're not locked into buying just Creo 7. You can buy whatever version makes sense for you, and there's people using all different types of versions of Creo or Pro Engineer out there. 50% off most extensions with Creo. Creo Simulation Live is not included in that, but most of the extensions for Creo are. So you get 50% off those extensions when you buy a new license of Creo. Now you can buy one license of Creo and purchase 50% off of several extensions, even for license that you have currently. So it's not limited to just the new license that you purchase, but also current licenses that you have. You can get those extensions too. You can also, if you purchase a new license of Creo, if you need 2 licenses, you get 50% off the second license. So buy one, get one half off. Also, if you have an older license that you haven't had maintenance or support for, that has run out, you can upgrade that license, and pricing starts at $1,700 annually for that license. And lastly, I'm going to launch this. If anybody's interested in any of these offers, just click and we'll get you some more detail on them. Lastly, learning subscription. So PTC right now has a learning subscription for $1,000 a year, and every single Creo license comes with an e-learning subscription, which basically means you have to go in, you have to train yourself and do it at your own time, which is great. Just we see a lot of people aren't taking advantage of that. So now there's these Creo learning subscriptions, and this learning subscription, what's different about it, in short, is that there is a certified PTC instructor online several days a week, and they might have a class that's set up for 3 different times during a day. So you could take something on advanced assembly. You could take something on mechanism design, like whatever you need to have training on, there will be a course online, a tutorial course available with a live instructor that you can interact with for a couple of hours. So the difference is, instead of getting training and being locked in for an all-day session or for an entire week, you can pick and choose with the learning subscription what you want to learn, what you want to brush up on, and you can brush up on anything, and it's only $1,000 annually. So I thought I would mention that. So that's going to conclude our webinar. Oh, one more thing. We offer 2 hours of desk side coaching for anybody that purchases a Creo subscription from us. We offer 2 hours of desk side coaching to help you understand specifically how to get up and running with Creo. I mean, our goal is to get you to use the software, so it's going to be a benefit, not just, hey, we sold it to you, good luck. No, we want to come alongside you, find out specifically what you want to model, what you need to do with Creo, so we can get you up and running quickly and using all the benefits and features of Creo that Creo has to offer to help you get your job done faster. So I want to thank everybody for being on today. I want to thank Bill Stickney, our panelist extraordinaire, as well as Paul Dye. Paul, I think you did a great job on the demo and the presentation. Excellent job. So once again, thank you everybody for being on. I'm going to upload the recording to our YouTube page, and we'll send this out to everyone. Thanks again, and have a great week, everybody, and have a great Memorial Day weekend. Take care.